Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
All right, welcome to WebRTC Live. I'm Arin Sime, your host, and here is a CEO and founder of WebRTC.Ventures, a custom development firm specializing in building live video applications. You can learn more about us at WebRTC.Ventures. And I'm very excited to have as a guest again today on the show our friend Dr. Alex. Dr. Alex is the CEO and founder of CoSMo Software, excellent WebRTC development firm, founder of the Kite framework for testing in WebRTC, part of the standards committees, and blogger at WebRTC by Dr. Alex. And Dr. Alex today is going to talk with us about AV1, an update there, and then a very timely topic that's being discussed a lot right now, end-to-end encryption specifically, but also touches on larger topics that are being discussed amidst the COVID-19 pandemic around privacy of video calls. So, Dr. Alex, thanks for joining us today.
Thanks for the kind introduction. So, last time I was invited here to speak, I was speaking about AV1, and at that time it was conceptual. I was speaking about what was going to happen. So I thought that I would do a little follow-up today for closure. AV1, real-time AV1 is now in Chrome. AV1 was in Chrome before, but only as a decoder for the media stream in YouTube, for example. Now it's integrated into the WebRTC stack. It's not compiled in by default in Chrome, but it's compiled in by default in libWebRTC. So anybody that is using the native libWebRTC in their SDK, they can go and have a try. They will see in the list of codec available to the AV1. So we made a website, and there is a blog post for anybody that is interested in more details. I just wanted to say it's here, and technically oriented people can start playing with it if they want. So on to end-to-end encryption. I'm going to jump over the H.265 news.
Sure. And just to confirm for our viewers, that blog post about the AV1 release, that's on WebRTC.com, correct?
That's correct. That's correct. Now I'm going to share my screen. I only have one screen, so that should be the one. And I prepared some slides because end-to-end media encryption is a nice story that took several years, right? So if I count correctly, 4 years. I'm going to specifically explain. There is a lot of people speaking about end-to-end encryption, and there is a lot of people saying different things. They cannot all be right, so I'm going to try to make things a little bit easier. What's the big deal, right? So why do we actually speak about end-to-end encryption? Well, end-to-end encryption try to answer the basic question, who do you trust? Do you trust your internet service provider not to spy on you, to protect your privacy and your content? Do you trust your media platform if you use one like Vonage, Twilio, or anybody? Or do you trust the people that provide the key to you? Who do you trust, right? So it's a little bit like having an apartment. You're renting an apartment or you're owning an apartment. You might have a landlord. Do you let the landlord have a copy of the key? Can the landlord come in when you're not there? Do you put the key under the mat so anybody that is going to look a little bit around is going to find it and be able to go into your apartment? That's a little bit like that. Even after that description, a lot of people will say, okay, I still don't see the problem, right? I'm supposed to use WebRTC, and WebRTC is end-to-end encrypted, so what's the problem? Well, that's right. WebRTC used in the original use case, which is P2P, is end-to-end encrypted, right? Because it's P2P. So you only encrypt it on the wire, and as soon as you reach the first destination, you suppose it's the final destination, and you end the encryption, right? So it's secure, but it's not scalable. Anybody that use P2P mesh design to do multi-party conference knows that very, very quickly you hit limitation, and you hit limitation with other things to connect to phone line, call in, call out, recording, and so on. This is much better with a media server in the middle. Now, if you put a media server in the middle, you can see that if you have Alice and Bob trying to connect to each other, now you have a transit. The media is leaving Alice, going into a WebRTC encrypted connection, reaching the media server, and then is encrypted again to reach Bob, right? So you have two hops. You have one transit on your way from Alice to Bob, and in that case, on transit, your media is not encrypted, right? And so, for example, the media server, if it was doing a recording, could do a recording of the raw content or could derive the raw content and send it anywhere else. So that's the problem, right? That's now you need to be able to trust the media server not to do the right thing, right? So if you look at Zoom blog posts and they say, oh, but we're not doing it. I'll say, okay, so you ask me to trust you, you're not doing it because actually you have the capacity to do it and I cannot check if you're doing it. Right? And since the Snowden revelation, we know that sometimes the platforms, be it ISP or media platform, can be legally forced or compelled to give access to their server legally without you knowing about it. Right? So it can be actually a government that is totally legally inviting your privacy without you knowing it. So if you only trust Bob with your media, you need to do something. So what you do, since you only have those blue hop-by-hop encryption provided by WebRTC, you're going to add another layer. So that's why sometimes people speak about double encryption, right? So you had a second layer that is inside that is going to protect the content even when the WebRTC encryption is not there. So in that case, the media server doesn't have the green key, cannot access to the raw content. So it could still record the content, but it can only record the encrypted content, and you still need to have the key. So if Bob, who has the key, access the encrypted content, he will be able to play it, but nobody else is going to be able to do it. This is all about web end-to-end encryption as compared to any other kind of encryption, right? So, okay, let's speak about the Zoom drama. Since the Zoom drama started, I got a lot of calls from people saying, is X supporting end-to-end encryption? X could be Skype, could be WebEx, could be anything really. I think I had them all, right? And it's difficult to give a yes or no question at first, but you can already say something. If they have a native app, if it's only native, it's possible that they're end-to-end encrypted. So you need to check if there is a second encryption layer, and then you have a list of questions to know if they not only end-to-end encrypted and they do it well, right? So who brings the key? How do you exchange the key? Who has access to the key? What is the impact if the key is getting stolen or compromised? So again, if you go back to your apartment, right? Let's say you have a fantastically strong door, armor door with whatever, you could fire a rocket at the door and the door wouldn't move. If you put the key under the mattress, people will be able to open the door very easily, right? So it's not only about how strong your encryption is. Your encryption is only as strong as your capacity to exchange the key securely. And that's something that a lot of people do not understand. The fact that the key management is really, really, really a problem, right? And so they bought an encryption that is really strong with a 2048 bits key and GSA and whatever. And then they put the key under the mattress with a panel on the door, return the keys under the mattress, help yourself. So the rule of the thumb is the list of questions is actually trying to check if at any given time, the keys are either publicly accessible by anybody looking, or if anybody in the system has access to both the key and the media at the same time. In the case of Zoom, it looks like they are the one providing the key, right? So since they are the one with access to the key and access to the media, even if they were end-to-end encrypted, they have the key, right? And so if you want to design a secure system, you need to separate the user, Alice and Bob, the media platform, and the key management system, KMS, in such a way that at any given time, only Alice and Bob can have both the encrypted data and the key. So the only one that can consume, display, and read that data. Oops, I went. So if you look at end-to-end media encryption, I'm going to remove the problem of the key. I'm going to remove the question of the key management system and so on. It's important, but you can treat it separately from the WebRTC application. So I will focus on WebRTC right now. I will focus on the media, and I'm going to speak right now about E2EME, which is end-to-end encryption, end-to-end media encryption. You can see 2 generations and a half. The first was PERC, and I'm going to go into the detail after, and the second one is S-Frame. Those 2 generations were native only, right? And only with the insertable stream API was end-to-end media encryption possible in the browser. And that only happened 2 weeks ago. So if you see someone that has a web app and tell you is end-to-end encrypted, that's not happening. That's a lie. You can call it out right away, right? So PERC and Secure Frame were originally a native-only technology, and 2 weeks ago, now there is an opening in the JavaScript API in the browser that allows that to happen for web app as well. So originally, back in 2016, 4 years ago, the communication expert at the IETF had already identified the problem of end-to-end encryption and, globally speaking, privacy-enhanced RTP conferencing, hence the name PERC, right? And so it was a little bit narrow. It was only for RTP conferencing, so it was useful for voice over IP using SIP and WebRTC. And so the job, the security design and the key design and the encryption design was made in such a way that it's not specific to WebRTC, but it can apply to any RTP-based communication. And it has been done very, very well, right? So I think a lot of credits and kudos needs to be given to the people that work on that at the beginning, including Adam Roach from Mozilla, who is in charge of the corresponding area at IETF, including Neil Solmeyer from Mozilla, who is in charge of both the media and the WebRTC stack and was the chairman of the PERC group. Callum Jennings from Cisco, that spent a lot of time explaining, especially the rotation of the keys and so on and so forth. Finally, we had a document to reference all that job. Actually, it's 4 documents, but here I'm only showing the documents that is dealing with the media encryption itself. So we call it double, for double encryption. And as you can see in the acknowledgement, a few of us, including Sergio, myself, and others, have been participating a lot and are given credit in the document. So at that time, really, the #1 company involved in the effort was Symphony Communication. It was a company that was funded by and for the banks, and that had some of the top 20 banks in the world as clients. And the idea was to have a secure communication at such a level that the SEC would accept it as a tool to do the usual bank business. They hired the WebRTC Dream Team at the time, and because they have class, they give them public credit. So people from GT, especially Emil and Boris, people from Meduse and CoSMo, and also people from Mythical. So some 3 of the main WebRTC open source SFU were involved in working, implementing, and giving feedback in the end-to-end media encryption for the past 3 years already. By 2017, it was time to get implementation feedback. So that the specification starts on paper, that at one point you start implementing it to see if it's actually feasible or if there is any corner cases, or if you can end up having interoperable implementation based only on the specification. If not, there is some gaps and you make the specification better. So we did a presentation with Don Burnett, which is the author of the WebRTC book and was the WebRTC spec editor. In 2017, we published a scientific paper with the Mythico team on the implementation in Janus. So Janus was implementing it in the Janus way, which was a unique peer connection without simulcast or anything. And we provide the corresponding source code for free to everybody. Then we did another job with Boris and Emil from Jitsi, specifically on the simulcast, to see what was the impact and the usability of the double encryption where you were trying to use simulcast. So this paper is a little bit more advanced, and it includes some evaluation of the bandwidth overhead, how much you're going to pay in terms of bandwidth and extra CPU when you use encryption. By the end of 2018, it was clear that PERC had some limitations. It did not support retransmission and other feedback mechanisms like forward error connection, which made bandwidth estimation and congestion control, so the capacity to adapt to the fluctuation of the network, very, very, very challenging. It was only limited to RTP as a media transport, while a lot of people had already shifted their interest to QUIC, and it was leaving the question of the data channel completely open, since we had already decided that we didn't want to do the data channel over RTP. And so going back to data channel over RTP was not an option. It was 5 years back. Finally, the bandwidth overhead was quite high because all the encryption extra bits were applied per packet. And it seemed to be an overkill. It had one advantage, though, is that if you were a big company with a lot of hardware out there, like Cisco, and you wanted to update your hardware to support PERC, you actually didn't have to bring the hardware back. You could do just a flash of the hardware, because the double encryption in PERC was just applying 2 times the SRTP API, right? That was already there. So that had a huge advantage for people that had a very big installed base of devices. Then in 2018, Google started an effort. Say, okay, we need double encryption. PERC is not going to do it. We would like to do it in a way that is more secure, use less bandwidth, and also not specific to RTP. And so they start doing work on this, their encryption and security team, but limited to H.264. And when they had something that started to work, they wanted to extend to different codecs and to try with different SFU. So they turned to us, since we had a few years of experience in the matter. And we worked together on doing SFU testing, optimization of the scheme, and how we can extend the proposed encryption scheme to VP9 and other codecs. So a presentation was made at TPAC in 2018 with the first results, but failed to get enough traction to become an accepted standard at the time. In 2020, fast forward, everybody is working from home, and though suddenly having collaboration tool and working on the web is really important. So all of the end-to-end encrypted clients out there, because there is no capacity in the browser, had to be native. And native clients need to be downloaded, they need to be configured. That it's a little bit too complicated for a lot of people, especially when you have most of the school trying to teach the kids from home. You either had to go fully public, right? Or that was it. So under the pressure of getting a web app that would have end-to-end encryption to be the equivalent of the existing native clients, Google went ahead and implemented the WebRTC NV API that allows to access the raw frame, the raw media frame, and the encoded frame, right? So we don't know who put most pressure on them, whether it's WhatsApp or Facebook Messenger, Duo. You can name almost any native-only end-to-end encrypted call software today that will enable them to have a web application. So that was one of the problems of Zoom. If you look at the drawing, On some of them, we're explaining that they can do end-to-end encryption, but not for everybody, because it's not possible from the people calling from a normal phone or from the people having a web app, for example. Well, now they can do it on a web app. No, my slide doesn't up. I got two slides. So what's the advantage of secure frame, right? It reduced the redundancy. It's the encryption is applied at one video frame at a time, and one video frame usually translates into 4 or more RTP packets. So instead of duplicated the encryption information over 4 RTP packets, no, you add it only for one frame, and you reduce the bandwidth overhead. It's not specific to RTP, so you can use it with QUIC, with WebSocket, with the data channel, with whatever you want. So it's actually pretty versatile. And it's been deployed by a lot of people in the native app so far. So now we have to be careful just about making sure that the web app implementation is at the same security level. So just like you would go to WebRTC.Ventures when you want to implement a very good WebRTC-based healthcare product, because they have years of experience, they've been there, and they've already done all the possible mistakes, and you get all that expertise with you. We bring 3 to 4 years of mistakes and knowledge and experience on end-to-end encryption, and put it in the software. So we also support Jitsi, Janus, Meduse for people that want to use different SFU vendors out there. Most of the end-to-end encryption modification is on the client side anyway, not on the SFU. You should not trust the SFU, so you're good. A few words as soon as the slide goes ahead on the web side of things. So let's go back to the Zoom drama. So end-to-end media encryption is very well documented. I gave you a list of references and paper and so on. And raw media, thanks to Google, is now available through a JavaScript API. So what's left to do to support end-to-end encryption in a web app if you want? Well, you have to implement your own crypto model. You have to choose a key management system. Thanks God, there's a lot of them. Apple has one, Google has one, Amazon has one. There's really a lot of choice, and they're all very mature. And finally, maybe something a little bit more tricky, you need to find a way to securely exchange the keys between the parties. And there again, there is another technology that not a lot of people are aware of, which is called MLS, which is here again a standard that the IETF made by all the people interested in security in the world. And there is a Netflix implementation with both a JavaScript version and a C++ version. So you have almost all the brick today to get things together. So I want to insist on 2 points. MLS by design is limited to 50,000 people, which might be a lot for video conference, but if you have a platform like Midicast.com that does video streaming to very large audience, that's not going to be enough. So there will be some extra work needed for some use cases. Then, how do you know if it's secure? The answer is always don't trust them, don't trust yourself either. Trust a security expert and get an audit. With Symphony Communication, when we wanted to give a secure solution to the bank, the ACC had some specific trusted audit partner that they would do that. If you go to the Disney studio and you want to sell them a remote tool for people to work on raw footage of the movie, they will have their own security audits subcontractor. And they're not going to trust you, but they're going to trust them. So you need to go through the audit, right? So in any case, whenever you try to implement a secure layer, always have an external, very, very well-known party to audit your code. It's almost impossible to get it right by oneself. So that's the end of the slide and what I wanted to say today. Maybe if you have some question, now we can move to the question.
Thank you very much, Dr. Alex. If anyone has a question, feel free to type that into the chat or the Q&A now, and we'll get those answered. So, so now with the insertable streams, as I understand, Dr. Alex, that was kind of the last brick that you needed in order to build a true end-to-end encryption in browser-based applications as well, correct?
Yes, that was the missing one. People underestimate the key exchange. That was one of the biggest reason why Mozilla didn't want to enable end-to-end encryption in a browser, because doing the key exchange or having the key available at the JavaScript level is usually not a good idea, to say the least. Right. So now with what didn't exist then and exists now is MLS. And so that changed a little bit the thing. The other point that people are making is that we already trust the JavaScript with the raw media anyway, right? And even if the secondary key is compromised, you just fall back to WebRTC. So it's like you have two locks on your door, right? The WebRTC lock, which is really secure, and the exchange of the key is secure. And then the application will be able to put a second lock on the door. So even if the lock is not really good or the key is under the mat, it doesn't change the fact that you still have the original WebRTC lock to protect you at least on the wire and during the transport, right?
Right, exactly.
So that's the two arguments of people that were proponents of the end-to-end encryption at the JavaScript level.
That makes sense. Great. Okay, so we have a few questions here in the chat. First,
so I'm going to take Nicholas Clark first. The question is,
sure.
Are there any SFU and/or client libraries available today that support end-to-end encryption? The answer is yes and yes. If the old PERC implementation is still publicly available, it's all open source, so it's first generation, but it works with Jitsi, it works with Meduse, it works with Janus. They have a specific branch on the server, and the modified libWebRTC is available. It's libWebRTC 61 and 65. It's a little bit old, but if you want to go there, you can. If you want to get S-Frame, Meduse is working today. So if you go look at our blog post last week, we actually provide link to a GitHub repository with a full example client-side and SFU that can do end-to-end encryption. And you have in libWebRTC, you have the API to inject the encryption module and the decryption module. So you still need to write the encryption module and the decryption module, and you still need to do with the key management. So we have some solution, but as far as we know, there is no open source solution to that. What is the best media server to use if I'm making a WebRTC conference? If I had $1 for every time I saw that question. It really depends on which language you like and the scalability. So usually for video conference, and if you're okay with Java, Jitsi is considered to be the best. Now, if you're more of a Go person, there is only Pion, and it's a good one, right? If you're more C, C++, there are more choices. You can go Janus, MediaSoup, Meduse. If you type WebRTC SFU, there's a lot of paper and lists that are going to go there, but you need to define your use case and which language you would like to use before people can actually give you a good answer to that, right? Do you know when the crypto module S-Frame will be publicly available? Will it be included in the WebRTC API? So you have the complete S-Frame reference document in our blog post, right? It will never be publicly available because it's an application layer thing and not a libWebRTC layer. So you inject it into, and it's your security and everything. So will it be included in the WebRTC API? By WebRTC API, there is an ambiguity. I don't know if you mean the implementation or the JavaScript. The answer is most probably no for both anyway. Some people will provide JavaScript implementation of different kind of crypto module. You can do something as stupid as just a hash or a do nothing checksum, and it works in principle. It's not super robust, and so you can put whatever encryption you want there. So we're working for a company, for example, that is really security focused, and they use their own crypto module. We didn't have access. during the development, and they have some fingerprint and actual device to deal with the key exchange and the encryption. So there is no limit, and I think it's better to say I give you an API to access to the raw frame, and I give you an API to inject whatever processing or transform you want to apply, and let the people do what they want to do with it, right? Matias Lopez, what about P2P connection? Where P2P connection, they already protected enough by WebRTC vanilla, so there is really nothing special to do about it. And in P2P transaction protected by WebRTC, there is absolutely no discussion about the generation and the transfer of the key, because it's done within the browser and not at the JavaScript level, and you cannot get that wrong. So you're actually more secure if you can do P2P today, because there's not a lot of people with experience in end-to-end encryption, so it's likely that the first one that are going to do it are going to get it wrong, right? And you don't know it's wrong until people hack you, right? So right now, end-to-end encryption, it's a little bit like teenage sex, right? Everybody wants it. Everybody say they're doing it. There's not a lot of people doing it, and it's likely that they're not very good at it, right? So people full of all the end-to-end encryption experts that didn't work on it or didn't work on PERC and the previous specification or standards, for example.
All right, I think that as someone else just also said in the chat, maybe one of the best analogies we've had in WebRTC Live. So thank you, Dr. Alex, there. Great questions, everyone. Thank you, Dr. Alex, for your time. Always enjoy the conversation. Appreciate the work that you're doing. And a very timely topic around end-to-end encryption. So thanks for taking the time to put that together for our audience. And for those of you watching, thanks for being here. Thanks for your questions. We'll post the recording live on YouTube and on WebRTC Ventures. And if you want to follow up with Dr. Alex, you can find him at CoSMosoftware.io or or by WebRTC by dralex.com. Let me say that again. You can find Dr. Alex if you want to follow up with him at CoSMosoftware.io or WebRTC by dralex.com. So Dr. Alex, thank you again for your time. Stay safe, and we'll talk to you again soon.
Thanks for having me.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.